Hello, this is question 1 on the Mechanics 2 paper from the International Edexcel papers from 2024, from January. And it's a variable acceleration question, quite common in the Edexcel specification. Remember that what you need to always remember for these questions is we have displacement. Sometimes it's called S, sometimes it's called X. This is in the x-axis. If we have displacement, we have to remember that differentiating the displacement, we get the velocity, because velocity is rate of change in displacement, and differentiating again, we get the acceleration, right? And the other way around, we have to integrate. So if we have the acceleration and we want the velocity, we integrate. In this question, they say particle P is moving along a straight line, fixed point O is on the line, and at time t second the displacement from O is this one here. Find the values of t for which P is at rest. So when something is at rest, what means is that the velocity is 0. So this is equivalent to say that the velocity is 0. So we have the displacement. Remember what I wrote here? We have to differentiate to have the velocity. So we are going to differentiate the displacement function to have the velocity, and that's what we are going to make equal to 0. So we have 6t squared minus 42t plus 60, just differentiating this expression, and then we are going to make this equal to 0. If we divide by 6 to simplify a bit, we have this, and when we have factorized, we have t minus 2, t minus 5, no? Equal to 0, which means when t is 2 seconds and when t is 5 seconds, the particle is instantaneously at rest. Yeah, so that's the first part, t 2 seconds, t 5 seconds. Then we have to find the distance traveled by p in the interval 1 to 3. Again, this is a very common question, and usually this is the first part. Why? Because if we have to find the distance, do you remember those questions? Oh, do you remember that if we represent velocity time graph, the area between the line and the x-axis is the distance, and that happens when we have straight lines, yeah, straight like constant acceleration or constant velocity, but it happens as well with these type of questions. So if we represent the velocity, this one is the velocity, the roots are 2 seconds and 5 seconds, so really it's a quadratic doing this. 2 seconds and 5 seconds I have the root, so 2 and 5, and they are asking us the velocity, the distance traveled between 1 and 3 seconds. So between 1 and 3 seconds, that means if we integrate this to find the area under, we have a positive bit, but then we have a negative bit here. So if we integrate our function between 1 and 3 without considering that there is a change of sign, we will get a wrong answer, yeah, because this is going to be negative, is going to subtract from this bit. So what we have to do in this case is like when we are finding the area in any function, we are going to integrate between 1 and 2, between 2 and 3, and then add them together. So that means that the distance is really the integral between 1 and 2 that is going to be positive of the velocity, and then the integral between 2 and 3 that is going to be negative, and then we add them, both of them together. The integral of v is already x, yeah, we really don't need to integrate, we have the function, so it's 2t cubed minus 21t squared plus 60t between 1 and 2, and the same for this one. So this will be the same function between 2 and 3 this time. If we substitute the 2 and then we substitute the 1 and we subtract, I'm going to give you just the answer because it's just, I don't want to copy everything, but I would recommend you in the exam, substitute the 2 minus substitute the 1. So leave clear you're working out. I don't want to keep you much longer in the video. So this is 11 and this is negative 7. So the distance is both of them, but positive added together. Yeah, so 11 plus 7, 18 meters. Yeah, please always be careful when you are finding the distance in this type of questions to check if there is a root in this interval. If there is a root in this interval, like in this case, the 2 seconds is in this interval, then you have to split it. You can do integrating, or you just confine the displacement when t is 2, when t is 1, and then the difference, and then when t is 3, when t is 2, the difference, and then add them together, but positive. And then the last bit is the magnitude of the acceleration of p when t is 3. So remember, the acceleration is the rate of change of velocity. So the acceleration is, as I said at the beginning, derivative of v. V is this function. Please don't use it simplified, because we have simplified because here we are making it equal to 0. Really, this is the velocity function. So we are differentiating that, and that's 12t minus 42. And the only thing that we do is substitute the t by 3 seconds. And this is 6. Magnitude, this is minus 6. 36 minus 42, minus 6 meters per second squared. But they say, look here, magnitude of the acceleration. And remember, the magnitude is always positive. So the magnitude of the acceleration, magnitude is equal to 6. Yeah, and that's what we need, or 6 meters per second squared, but positive. Remember, magnitude is always positive. And that's all with this question.